Hello, my name is Rolf Green, and today I'm going to be doing the presentation on the Alpaca Research Investment Chart. But before I get started, I would like to first demonstrate to you the chart so that you can see the example of it and know what it is that I'm talking about as I continue the presentation with the PowerPoint. In the bottom right, you may be able to see that there are three files here. They're called Alpaca Stock Chart, uh, Dependence Injection Martin, and then there's the other one, Alpaca Stock Chart, Dependence Injection Real, and then the Alpaca Stock Chart Base. As we go through the PowerPoint presentation, as you can see here, you will find that there are illustrations, but I thought I should give you the benefit of seeing how they actually work when we're using the command prompt. If it's visible on your screen, I would use the Python command to start a chart. In this case, I'll start the very first one. Alpaca stock chart base. It will present to me some information I need in order to open up the chart. Takes a moment. There we go. Finally appears. I copy the URL to go to the local host to see the chart assembled. This is the base chart as it appears. First of all, I got to go to a browser, which is in this case Google Chrome, and we'll hopefully see it open. Okay, opens to Google, and I'll paste in the local host URL and hit return. As you can see, the Alpaca lightweight chart with real data for 30 days appears. And I can change the stock symbol to see another chart. The look back date is also addressed to change. 15 days, 30 days, 60 days, 90 days. Initially, we didn't have the look back period, and that was a part of the task of the project. So this is the Alpaca lightweight chart real data. And we can use another stock symbol in the menu to see Vistra. This is apples right here, and you can see the prices start from 165 to 225. As we go to another stock symbol, Vista, it will change the data. We update the chart, and here you see Vistra, VST, changes the data. We can change the number of days we're viewing. As you get into longer days, it will have smaller bars. We update the chart, as you can see here. So the charts are working, and they're working with the Python command. As you may have noticed, I'll close this now. There are two other files. One is marked and one is real, and that's to demonstrate the injection for mark and for real, as we'll go on to explain. Dependence injection. First of all, I'll close the command prompt with Control C, if it will allow me to. There we go. That's closed cleanly. And that was also something that we had to adjust. And I'll try to do the dependence injection with real data using the Python command. It's going to create, allow for some flexibility. Okay, we're using real data. Using dependence injection real. And as you note, it takes a moment to get it. There we go. This one worked a little faster. And we have here a URL for the local host. It's usually using the 5000 port. And we can open up Google Chrome for the local host. Let's see if we can do that. Okay, I got two of them. I just need one. Let me close one. Close two. Just a moment while we get one browser up. And I'll paste in the localhost address or URL. It will open up the lightweight chart, and it shows the real data for APL, which is Apple, for 30 days. We can change the days from 15 through 90, and we can also change the stock symbol. But I just want to show you that we can use dependence injection to obtain real data, and we can use it to obtain mock data, and we'll do the mock data next. I will close this chart and also close the program operating in the command prompt with a Control C, and it did a clean close. And we'll try the chart with the mock data using the Python command. Okay, Alpaca, stock, chart, dependence injection, mock.py. This is the third chart that we're going to visualize, which uses mock data rather than real data. And it's useful to have mock data for testing purposes to confirm that we have the flexibility we need in our program that is doing injection and even factoring. So let's go to the command to the Google Chrome to the localhost with the URL that the program provided. The localhost URL. And there we go. Oh my! Kind of. Let me paste that in again. There we go. And we should see the mock data, and then we do. Up here in the label or the heading, it says mock data, and it's mock, so it has a very rigid bar chart. And we could conceive of the mock data may not change, but in this case, because we updated it and enhanced it, we can actually change the mock data to Vistra or well, let's say Google. And we can update the chart 15, 30 day, 90. So this is the Google prices using the mock data. I just wish to illustrate to you these charts are working using the dependence injection. I'll close the chart now, and we'll get on with the presentation, and I'll additionally close the command prompt using Control-C. And that worked just fine. Clear things up, CLS, and we're ready to move on to demonstrating the chart, the Alpaca stock chart. And as you can see, it shows a little illustration of the stock chart. And in this case, it's the Alpaca lightweight using real data, the first one that we saw. Welcome to my progress review for tasks 1 and 2 of the Alpaca Research Investment Chart project. I'm Ralph H. Green, and today is Friday, May 2nd, 2025. In this presentation, I'll walk you through the development of my stock chart application from initial bug fixes to advanced features like dependency injection, and share how those improvements support my goals of stock analysis and forecasting. Let us go to slide 2 on the progress report. In the progress report, you'll note we started with timeline in week 3, and I originally began with the Singleton app, which is a singularity, a real app in here, and we were able to enhance it to work very well. And it evolved through several versions. I fixed a typo in the original file, implemented the Singleton pattern, and added optimizations in version 2. By version 3, I introduced a configurable look-back period, tested the enhancements, and built a progression from version 1 to version 3, resulting in Singleton Real App Enhanced version 3.py. This laid a strong foundation for the project. The illustration or the chart is similar using Singleton. It just doesn't have the flexibility that it would have when we're using dependence injection later. In slide 3, and as you can see, the optimizations were added to version 2 and version 3. And I renamed an original file to versions 1, 2, and 3. As you can see here, built version 1, version 2, version 3, into Singleton Real App Enhanced version 3. It was really a great experience being able to enhance that original Singleton file. We move on from there to slide 3. It shows the use case diagram of the Singleton primarily. It was kind of an adventure to use the Singleton program because it uses get instance in its application. The Singleton Alpha Research Investment Chart has a user who interfaces with an API that includes the fetch stock data when he inputs the ticker symbol. And that includes a stock chart presentation based on a look back, which we added. That was one of the enhancements that we added to the Singleton, was a look back, so that you can look at 15-day, 30-day, 60, or 90, just as we did later with the DI. We'll move on from there. You can maybe that chart, maybe that diagram isn't as big as it might be, but in any case, hopefully you can see it pretty well. It's 3 basic uses. And let's see, slide 4. The initial chart for AAPL is the 30-day look back, which I just showed you a moment ago. See, that's the 30-day look back using the original Alpaca lightweight chart. It has real data. I showed you how I did that with the Python command a moment ago. This slide shows the initial chart for Apple with a fixed 30-day look back displaying real candlestick data, and you notice the candlestick. The chart titled Alpaca Lightweight Chart Real Data allows users to visualize stock price movements. You can see Apple's price dropping to around 169 before recovering to 210 by the end of the period. This chart was a starting point for analyzing stock trends, but it lacked flexibility in the look-back period until I was able to enhance it. Okay, let's go on to slide 5. Slide 5, we're looking at real data, but the difference here is that we're looking at 90 days of it. To improve flexibility, I updated the chart to support a configurable look-back period using a drop-down box. Okay, the drop-down box allows you to select 15-day period, 30-day period, 60-day period, and 90-day period. In this case, it's 90 days that we're looking at with narrow bar charts and also the candlestick. This chart shows Apple with a 90-day look back, revealing a broader trend. They peak at 250, that dropped down to 169 in recovery to 211. This enhancement allows for deeper stock analysis over different time frames, which is crucial for understanding long-term trends. We move on now to slide 6, which is the 90-day look-back chart and what it encoded. I guess we did look at the 90-day look-back. Yeah, that's what we did here. In any event, my slide moves on to the code snippets. One of the initial bugs that we had in the look-back would involve the early portion of development. I encountered the syntax error OCERN in the code snippet. As you can see here, it was the Flask environment for the development, and it was incorrectly spelled. And it had to be fixed from OCERN to os.environ. And you can see how a simple spelling error can cause an error, cause a program not to work. Okay, we move on to slide 7. Moving average issue came up when we were trying to add more features to the chart. In version 2, I faced an issue with moving average alignment. The initial code had an indexing mismatch, causing the chart to disappear. The snippet shows the incorrect approach where I directly indexed the moving average series. I fixed this by properly aligning the indices, checking for valid data, and ensuring the 5-day moving average rendered correctly on the chart, enhancing its usefulness for trend analysis. So here's the incorrect snippet here. And the fixed proper alignment snippet appears here. Fixed chart disappearance by aligning moving average indices with a time frame for candlestick value. And the float applied. Let's move on to slide number 8, I believe. Another issue in version 2 was syntax error due to a missing bracket. And this is a simple error. We can often forget to add a bracket. In the common problem, syntax error, missing bracket, the code snippet showed incorrect missing bracket, candlestick bars for timestamp. It was just truncated. And then we fixed it by adding the complete statement and the bracket following. There we go. There's a bracket here. Let's move on to slide 9, testable code summary. In testable code summary, we found techniques for testing and enhancements. And this was a big jump, a big kind of leap forward, more improvement. We use code modularity. We're moving away from the singularity of the singleton code and the get instance to the modularity of separate programs. even in the original program, there's a separation of the modular aspects, get instance and get data, and it works kind of as a model for um, modularity and later for more flexibility. Where are we? We should be in 9. Okay, techniques for testing and enhancement. Code modularity adheres to single responsibility principle. For example, get instance, get data. And dependency injection used to switch between real and mock data. And that gives us more of a handle on how our computer program operates if we can use a mock data test. Now the mock stubs used mock data in week 3 to bypass port 5000 error, and that was something I worked out when I had successfully created a original file using mock data. It allowed me to progress to a successful application that didn't have a port 5000 error that was stopping me at the time. In addition, we did the testing with 10-unit integration test successfully. At first we had some failure, of course, and we had to work through it with troubleshooting. Okay, we're going on to 10, slide number 10, unit and integration test in Alpaca. Now we're getting pretty advanced here using troubleshooting steps to test every bit of the code. Unit tests isolated components like get instance and get data of the singleton code. In an example, we were able to verify get instance returns the same singleton instance, and we demonstrated singularity with the singleton pattern and modularity with its isolated functions. I used the singleton for configuration mainly to provide additional security to the program in which we're presenting the Alpaca research investment chart. The integration test between components, for example, Flask app with data fetcher. Example would switch between real and mock fetchers, checking chart rendering. And it demonstrated dependence, mocking API, and DI, which is dependence injection for swapping the fetchers. The impact is that it ensures reliability for stock analysis and supports forecasting with mock data. Here we have a visual table showing the type of test. Unit test, isolated components test get instance for singleton, and singularity or modularity. In the integration test, we check component interactions, testing Flask app with real or mock fetchers, and dependence injection. Let's move on to our next slide, number 11. Okay, in 11, we talk about its strengths and what works well. Here are the strengths of the code. It features robust data fetching and chart rendering, optimized with pandas.rolling. It's a function with parentheses for moving averages and TTL catch for caching. The configurable look-back periods adds flexibility, and the secure singleton pattern ensures consistency in the investment app. These strengths make the app reliable for analyzing stock data, such as Apple's price movements. I later used mocks in week 3 to bypass the port 5000 mock application, actually, to bypass the port 5000 error. And in week 4, I wrote 10 unit and integration tests, which I explained in the previous slide. These techniques improve the app's reliability for stock analysis. Okay, let's move on to slide 12. We're making great progress here. Okay, weaknesses, areas for improvement. We had limited front-end interactivity at first, for example, a no symbol drop-down, and we were able to add that. We had error handling needed improvement, for example, with network failures or other failures that limit robustness. And then we had cache setting issues, which would need tuning for scale down the road. And we lacked support for different time frames. And we provided drop downs for the time frames, but maybe additional support would enhance that further. In addition, we can move on to slide 13, our evaluation for dependence injection. What is dependence injection after all? Definition here is dependence injection is a design pattern that allows swapping dependencies, for example, data sources, without changing the core logic. The purpose for it in Alpaca project was to switch between real stock data with using the Alpaca API and mock data for testing. The key components are an interface data fetcher, which defines a fetch method. Implementations such as Alpaca data fetcher for real data and mock data fetcher for mock data. And injection, where I choose the implementation at runtime. This is controlled by oddly by comments when you use one mock or the other real data application. And let's say we move on to slide 14, how we use DI. And this may give you a clearer illustration on how that was done. The implementation shows here. It might be too small for you to see, so I'll try to view it larger. Let's say 100. And I'll see if I can swing over there. Yeah, I hope that's more visible. And the implementation shows in slide 14 how I implemented DI or dependence injection in the Alpaca stock chart project. I defined a data fetcher interface with a fetch method and created two implementations, Alpaca data fetcher for real data and mock data fetcher for mock data. The mock data fetcher generates dynamic mock data based on the ticker symbol. For example, AAPL starts at 220 and trends up, while VST or Vista starts at 80 and trends down. I injected the fetcher into the Flask app by selecting one at runtime, and I can switch between real and mock data by commenting out one line, as shown here. One line would be commented out, and it's the line that would be actually fetching here mock data. You can see that there's no comment for the fetcher, and so on. There you go. These side by side, let's see about the charts. I presented the charts at the beginning so you would be able to see them, so we wouldn't have a limited space to see them during the PowerPoint presentation. And then in the diagram I show how the dependency interjection works conceptually. Let's see, where is the diagram? Slide 16. Okay. Here we have a diagram. It's right here. Actually, I need to view down to, let's say, 75%. And this shows how the Flask app works using the data fetcher interface. It can either choose Alpaca data fetcher for real data or mock data fetcher for mock data. And then we're getting back up again, let's say to 15. We covered, oh yes, why DI matters for stock analysis. Testing without API mock data allows testing without hitting the Alpaca API limits. And I'll increase this a little bit to 100. Yeah, let's get over a little, maybe you can see a little better. How's that? For example, I use Google, and the mock data starts at 100, trends up to 10 cents a day. And the flexibility allows us to switch between real and mock data with just one line of code, which we either comment or not comment. In the real data application, the Apple starts at $211.03 for May in a 90-day look back period, which we can select, as I pointed out when we did an example run. In the mock data, we could also do VST, and I added coding so you could do simple changes even in the mock data. Dynamic mock data, updated mock data fetcher to generate scenarios based on ticker symbols. It supports my goals to analyze real stock data and forecast trends with mock data, providing a little additional control. In the visuals, I showed the Alpaca research investment charts, including the real data for 90-day look back and the mock data for 90-day look back. And finally, we're going on to, I showed the diagram already, show you how that chooses the fetcher. And here we go on to the slide regarding future work and improvements. And let's view that a little bit closer here. What do we have in mind for future work and improvements? Well, there's evaluation to consider for future steps. And the success we had in fixing bugs added optimizations and configurable look-back periods. The techniques we used were dependency injection, code modularity, mocks, and testing. In the future, we might want to enhance the front-end support for timeframes and improve error handling, and in addition to the use case diagram again, being tied back to user interactions as I showed in the stick symbol diagram. Let's go on to the conclusion. This has been coming to the end of our PowerPoint video. Thank you for participating in this slideshow. This completes the presentation. I hope you find the chart representations useful and their enhancements helpful.